Dear colleagues and friends, my name is Wei. I'm now a PhD student in University of Liverpool, School of Architecture. This research focused on developing adaptive sum-confidence models and evaluation criteria for rural low-income residents in China. In the past 30 years, urban areas in China benefited a lot in the booming development. However, at the same time, rural areas were left behind. Urban residents enjoy fast income increasement, convenient infrastructure, comfortable living and working indoor environment, while rural residents are still living in outdated houses with uncomfortable indoor environment, especially in winter and summer seasons. In rural houses, indoor temperature can be as low as 5 degrees in winter in northern China. Increasing reliance on air conditioning to improve the thermal comfort in rural houses results in high energy bills, causing financial stresses for those vulnerable rural households, as well as higher carbon emissions and other environmental problems. As defined by Nico and Humphreys, because context, culture, buildings, and climate are unique to any particular place, so also our comfortable needs and expectations of its inhabitants. So, is it possible that those rural low-income residents have acclimated to the environment and formed unique acceptance and perceptions? Some previous researches have found differences in thermal perception and acceptability in between rural and urban residents. In this research, field surveys were carried out in Lancao County in northern China for the following reasons. This is the daily outdoor air temperature during winter and summer field surveys. This is the distribution of recorded indoor operative temperature. In winter, the majority of rural low-income houses hold excessively cold indoor thermal environments. In summer, the indoor thermal environments are relatively comfortable. This is the distribution of thermal sensation vote and the thermal acceptance vote. Despite of the indoor thermal environment, the majority of researched occupants seems to be satisfied with their own indoor thermal conditions. This is the plot of adaptive thermal comfort criteria in ASHRAE Standard 55 and the field survey data. This is the plot of EN standard. Winter data are not plotted here, as the EN standard is not applicable in winter season. This is the plot of the Chinese standard and field survey data. It is obvious that none of the three standards are applicable for researched residents. This table shows the adaptive thermal comfort model for winter and summer conditions. Griffith's method provides the theoretical basis for this analysis. The next step is to determine the 80% and 90% acceptability range. Width of the acceptability ranges is usually derived from bell-shaped curve of regression of thermal acceptance vote on indoor operative temperature. However, in this research, winter and summer conditions are researched separately and no mid-season data are available. Therefore, two half bell-shaped curves were acquired. There's no possibility to calculate the width of the acceptability range with this method, but we can still get the lower extremal temperature of winter acceptability ranges and upper extremal temperature of summer acceptability ranges. Another method for the calculation of width of acceptability range It's through the weighted linear regression analysis of mean summer sensation vote on indoor operative temperature. Gradient of the line determines width of the acceptability range. The more gentle the slope is, the wider the acceptability range is. The upper and the lower boundary equations of 80% and 90% acceptability ranges are acquired by adding an offset to the adaptive model developed above. Offsets are half of the width of the acceptability ranges. After plotting upper and lower boundaries and the extrema in Figure 12, we are able to acquire 80 and 90% acceptability range for winter conditions. Criteria can be used to determine acceptable indoor operative temperature and evaluate comfort level of indoor operative temperature. This is the evaluation criteria for summer conditions. Conclusion. Majority of the researched indoor environments are extremely cold in winter, but a great number of the occupants seem to be satisfied with the indoor thermal environment. Indoor thermal environment seems to be relatively comfortable in summer. A great number of the occupants seem to be satisfied with the indoor thermal environment in summer. At last, local and specific adaptive criteria were developed for winter and summer conditions. Future work. More discussions will be conducted on the two criteria, and continuous field survey data will be updated to database to improve the accuracy of new adaptive models and criteria.